What if our universe isn't the whole universe? What if our universe is not actually the whole of the great universe, but only a part of a much larger cosmic world? In fact, the confusing discoveries of the James Webb Telescope have been raising the question for some time now of whether the development of the universe really could have happened as generally assumed. After all, Webb repeatedly tracks down equally early and enigmatic objects that, according to our understanding, should not actually exist. But assuming that other universes really do exist alongside our own, how could we possibly detect these hidden parallel worlds? The exciting answer is that we may have already done so, and that the direct relics of a predecessor universe are actually out there. The James Webb Telescope is keeping the astronomical world on tenterhooks, and is now regularly reminding us that we are still a long way from having solved all the mysteries of the cosmos. Unexplainable galaxies and black holes. There are, for example, the 6 unexplainable early galaxies, which were as massive as the Milky Way is today, a good 13 billion years ago, and which thus stand in stark contradiction to current cosmology. The situation is quite similar in the case of the galaxy JADES GS Z13-0, which existed as early as 290 million years after the Big Bang, and is also surprisingly large and full of stars. But how is this even possible? How could there have been such massive star clusters at that time if our standard model says that the normal matter required for this simply did not yet exist? Well, the perplexed astronomers point out that the matter density in the young universe was either 2 to 5 times greater than generally assumed, or that the galactic early birds grew in a completely different way than previously suspected. Either way, these so-called universe breakers are putting the experts in a difficult position. But the same also applies to completely different objects. In fact, the James Webb Telescope has identified a black hole that existed just 770 million years after the birth of the cosmos. Despite everything, it already weighed over 1 billion solar masses. The researchers analyzed the feeding mechanism of this gravity monster, but to their own amazement, they found nothing unusual. Apparently, the black holes of the early universe grew in a similar way to their later counterparts. In other words, we apparently know significantly less about the development of galaxies than we thought. The speed of the universe, the Hubble tension. What we do know, however, is that the universe also behaves idiosyncratically when it comes to speed, more precisely, the Hubble constant, which indicates the speed at which the universe is currently expanding. On paper, the expansion rate is around 67 kilometers per second per megaparsec. A brief explanation. 1 megaparsec is about 3.26 million light-years, while 1 light-year is 9.46 trillion kilometers. In other words, this means that the speed at which galaxies move away from each other increases by 67 kilometers per second every 3.26 million light-years. That's an impressive 244,000 kilometers per hour per megaparsec. But it can be significantly faster than that in practice. And this is the crucial point. Our theoretical predictions simply do not match the real observations in space. Direct measurements based on supernovae, gravitational lenses, variable stars, and red giants have shown that the value of the Hubble constant is actually 73 kilometers per second per megaparsec. This, in turn, corresponds to 264,000 kilometers per hour per megaparsec, a deviation of 20,000 kilometers per hour from the theoretical value. This expansion puzzle, which experts collectively refer to as the Hubble tension, was recently confirmed once again by the James Webb Telescope, after Webb re-examined the data previously collected by the Hubble telescope. It was once again established that the universe is simply not doing what our understanding says it should. The overall result this time was also a Hubble constant of 72.6 kilometers per second per megaparsec, rethinking the Big Bang and the structure of the cosmos. But what do all these confusing findings actually mean for the big picture? If we have been so mistaken about the development and expansion rate of the cosmos, could it be that we are also on the wrong track when it comes to much more fundamental issues? What if the much-cited Big Bang also happened quite differently than generally assumed? And what if our universe is ultimately just a piece of a much more complex cosmic puzzle a cycle, a multiverse, or something completely different? Well, the perhaps somewhat surprising news is that such theories are anything but new, and they have been the subject of serious discussion among experts for quite some time. And although the idea that our cosmos is not unique may sound like science fiction at first, parallel universes are by no means inconceivable from a purely physical point of view. In fact, they may even be probable. Penrose's cyclic universe. One approach is based on the assumption that our universe is subject to an eternal cycle of destruction and resurrection. Its most famous advocate is British Nobel Prize-winning physicist Roger Penrose. Penrose is convinced that the universe will eventually return to an extreme state from which it can explode into a new existence, again and again. The cosmos would continue to expand until all matter has disintegrated and become light, maneuvering itself into a state in which nothing has a time or space reference anymore. According to Penrose, this inevitably leads to a new Big Bang. But assuming that this cosmic cycle really reflects reality, wouldn't there have to be some tangible evidence for it? Actually, yes. And according to Penrose, we have already found it. More specifically, these are the so-called Hawking points, which could be direct relics of a predecessor universe. As black holes evaporate completely into Hawking radiation at the end of a cosmic era, they would transfer this energy into the subsequent universe in the form of Hawking points. In theory, these telltale remnants of microwave background radiation look like disks about the diameter of the full moon. In practice, Penrose's team has detected exactly that in data from the Planck and WMAP satellites. The mirror universe. Another compelling theory is that of the mirror universe, which states that our universe has an inverted twin. In simple terms, this hypothesis assumes that the Big Bang marked the beginning of two universes with opposite properties. This would mean that in the twin world, there is more antimatter, mirrored spatial conditions, and even time running in the opposite direction. This idea can even help explain some profound questions, such as why there is more matter than antimatter, why we only know left-handed neutrinos, whose spin runs counter to their motion, how dark matter might be created, the infinite multiverse. If mirrored or cyclic universes are still not enough for you, consider the multiverse. This is based on the model of chaotic inflation, developed in the 1980s by Russian cosmologist Andrei Linda. This theory proposes that after the Big Bang, the cosmos expanded faster than the speed of light, triggered by a scalar field that takes on random values at each point. In some places, the values are just right to spark inflation. In others, they are not. As a result, some regions of space expand faster and earlier, creating bubbles. Each bubble represents a universe, and this happens over and over again. Our universe, then, would be just one of many bubbles in an infinite cosmic foam. But what might our neighboring universes be like? It's possible that they also teem with stars and galaxies, but perhaps they are governed by entirely different physical laws, or have no matter at all. If an infinite number of universes really do exist, then they contain an infinite number of variations in laws and conditions. Each world would have its own individual parameters and settings. In our world, those settings are conveniently tuned to produce beings like us, beings capable of wondering about the very secrets of the cosmos itself. You no longer have to worry about missing a video from us again. Just press the thumbs up and subscribe now to stay up to date. We'll see you soon.